This video explains why every stoichiometry problem goes through moles even when the question gives you grams. So, a really common question that students often ask is why can't we just use grams in stoichiometry? Well, grams don't work in stoichiometry because the mass of a substance depends on what the substance is. So, for example, if I have 1 mole of hydrogen gas, then that is 2.02 grams. Whereas if I have 1 mole of oxygen gas, that is 32.00 grams. So they have the same number of particles. Both are just one particle here or 1 mole of the substance, but their masses are vastly different. So 2 grams versus 32 grams is hugely different. So that means a gram of hydrogen and a gram of oxygen don't represent the same amount of substance. And stoichiometry is all about comparing amounts of substances in a reaction. If grams represent different amounts depending on the substance, then we can't use them to form ratios. We have to use moles to form our ratios. So grams can't be used directly in stoichiometry. We need a unit like moles that represents this amount in a consistent way. So, like I said, grams don't work for comparing substances. So, the question is, what does work? Well, let's look at a balanced chemical equation and think about what it's actually telling us. So, in this equation here, we have 2 hydrogens reacting with 1 oxygen to form 2 water. So those numbers in front of the formulas, so the 2, the 1, and the 2, are called coefficients, and they tell us how many units of each substance are involved in the reaction. They don't tell us anything about mass. At the particle level, what this really means is that we have 2 molecules of hydrogen and 1 molecule of oxygen producing 2 molecules of water. Because a mole is a way of just counting particles, that same ratio also applies to moles. So we have 2 moles of hydrogen reacting with 1 mole of oxygen to make 2 moles of water. So when we read ratios from a balanced equation, they are always mole ratios. And that's really important in stoichiometry because it allows us to compare different amounts. So if stoichiometry ratios are always in moles, you might be wondering where mass actually fits into all of this. And in real problems, we usually measure substances by mass, not by counting particles or moles directly. Mass is how we usually start a stoichiometry problem and sometimes how we finish, but it's not what we compare. Because that chemical relationship is in moles, we have to convert mass into moles before using a mole ratio. And then if the question asks for mass at the end, we convert it back. So if we're given grams, then we first need to convert that to moles. And then once we have it in moles, we can use our mole ratio, and that'll give us our moles of our unknown. And then if need be, we can convert it back to grams at the end. So this is our known values here. And then this is what we're trying to solve for, or our unknown values over here. And so every single stoic problem is going through, if it's mass-based, it's going through this exact pathway. So what doesn't work is trying to compare grams directly using the coefficients, and we need to be able to go through moles. You can think of moles as our bridge between the two substances. Let's see if I can spell bridge. There we go. So let's put this all together and look at the big picture. And we can think of this as our stoichiometry roadmap, where we usually have stoichiometry problems, especially if they're mass-based. We usually start with grams because that's how quantities are measured in the lab. So the first thing we need to do is we need to always start with a balanced chemical equation. We're then given grams, so this is our known values. And we need to convert that to moles using moles is mass over molar mass. Once we have the moles of our known, we can set up our mole ratio or our bridge to find the moles of our unknown value. And then from there, to go from moles to grams, we're going to do mass is moles times molar mass to get the grams of our unknown value. So moles are the bridge between what we measure and how chemicals actually react. No matter what the substances are involved, this pathway is never going to change. So this is our guiding roadmap for stoichiometry problems. Once you understand this pathway, stoichiometry becomes much more predictable. And now that you've seen why stoichiometry always goes through moles, the next video is going to show you how to use this pathway to solve problems when the given quantity is in grams. That video is linked on the screen now and in the description below. Go check it out, and we'll see you there.